So today we are going to focus on the topic Bohr's effect and buffering effect, right? In our previous lesson, we have talked about the hemoglobin dissociation curve, in which we have seen or we have discussed that how the hemoglobin saturation takes place in the lungs, because in the lungs the hemoglobin saturation is possible because of the higher partial pressure of oxygen. Now the question arises that when Bohr's effect is our topic, Bohr's effect and buffering effect of hemoglobin. Buffering effect of hemoglobin, right? So Bohr's effect and buffering effect, we are going to focus on this first, right? So when we talked about the hemoglobin dissociation curve, I told you that when there is higher oxygen partial pressure in the alveolar lining, or you can say in the alveolar cavities, right, there is more oxygen present, due to which it diffuses into the blood and reaches to the hemoglobin present in the red blood cells. And then it binds to the hemoglobin through cooperative binding. Cooperative binding. Cooperative binding, I told you that when one hemoglobin molecule binds, one heme group binds to the oxygen molecule, causes the distortion in the hemoglobin molecule to cause the second heme group to get exposed to the oxygen, so that the oxygen can bind with the heme group, and then the second molecule causes the distortion in the hemoglobin molecule, so that the third molecule of heme group can get exposed, and then the fourth, right? So this is what do we mean by cooperative binding. And this cooperative binding when makes the hemoglobin saturated with oxygen. Now this blood through pulmonary vein will be brought back into the heart, and then heart supplies that oxygenated blood to the tissues of your body or the cells of your body. For example, if these are few of the tissues, or you can say the cells of your body that needs oxygen, right? And we can say that they are the respiring tissues of your body, right? And this is the, we can say, the capillary that is present in the surrounding of these tissues, right? And this capillary is basically, you know, that it is one celled thick, right? These are the epithelial cells that are present, right? And in this capillary, you know that plasma is present, the red blood cells are present, and they are moving in the blood plasma, right? This is blood plasma, or you can say the blood in which the red blood cells are moving in near to the tissues, right? So when these tissues are respiring, these tissues will give off carbon dioxide in the tissue fluid. And this carbon dioxide from the tissue fluid, this place will be having tissue fluid here, right? And tissue fluid, you know that how it is made. And this tissue fluid is involved in the exchange of substances, right? So when this tissue fluid is present in the surrounding of the cells, this carbon dioxide from the tissue fluid diffuse into the blood capillary and then reaches to the hemo reaches to the red blood cells where the hemoglobin is also present. Now the question arises what this carbon dioxide will do in the red blood cell, right? Let me make it a little bigger for you so that I can show you that what happens inside the red blood cell. Let's suppose this is a big red blood cell I'm making in front of you, and this is the carbon dioxide that is being diffused from the tissue fluid and reaching into the red blood cell. And this is the capillary lining, right, where the red blood cell is present. Now, this carbon dioxide, when comes into the red blood cell, reacts with water, right? And can anyone name me the, Ans, please name me the enzyme that is used to make these two carbon dioxide and water to react together. I told you in my last class as well. Yes, Ans?
मैम वो आप रिपीट कर सकती है
Very good question. The enzyme name is carbonic anhydrase. The enzyme name is carbonic anhydrase enzyme, right? And this enzyme, when will make carbon dioxide and water to react together, it makes carbonic acid, H2CO3. right? And what is the product? That is carbonic acid. And then this carbonic acid further dissociates into carbonates, HCO3 negative ions, and hydrogen ions, right? So when these two compounds are formed, right, what will happen? That these two compounds, that is more hydrogen ions, will disturb the pH in the red blood cell, may cause the enzyme, that is the carbonic anhydrase enzyme, to get denatured. So this, to prevent this denaturation of the enzyme inside the red blood cell, these hydrogen ions needs to be neutralized, right? And at first, they should be sent outside the red blood cells so that they don't cause direct damage to the carbonic anhydrase enzyme, right? So for that, here there is a process that occurs that is called as chloride shift. Chloride shift. Now let's see, what do we mean by chloride shift? All this is happening to cause Bohr's effect, right? I'm telling you, I will come back to these two terms, Bohr effect and buffering effect in the blood, because this carbon dioxide may cause the pH change of the blood, and this should not happen unless we can die. So this all is happening to cause these two effects, that is Bohr's effect and buffering effect. We will talk about them. The first, what is happening next, that is chloride shift. The chloride ions that are present outside in the plasma may replace the carbonate ions, and the carbonate ions will come out of the red blood cells. When this carbonate ion will come out of the cell, these hydrogen ions are also come, you can say, outside the red blood cells, so that the pH can get neutral inside the red blood cell. Now the question arises, when these hydrogen ions will come outside, ma'am, so don't you think that the pH of the plasma will also get disturbed? It may cause other damages. So when this chloride shift is happening, there are certain advantages of this chloride shift. One of the advantage of this chloride shift is that it will keep the negative charges equal on both the sides, across the membrane of the red blood cell. That is, equal amount of negative charges will be there on the inner side, and equal amount of negative charges will be there on the outer side of the red blood cell, that is in the plasma, right? This is the first advantage, to you can say, keep the concentration of negative charges equal. The second advantage of this chloride shift is that it will allow the hydrogen ions to come out, and these hydrogen ions, when will come out, right, may not cause the direct damage to the carbonic anhydrase enzyme. And then when the pH of the plasma, obviously these are hydrogen ions, and these hydrogen ions definitely, when will increase in the plasma, can also be one of the cause of disturbance in the pH. Now, because of these hydrogen ions, what will happen inside the red blood cell? That this will be a stimulus, that the hemoglobin that has got oxygen attached with it will give off oxygen to the respiring tissues, where the tissues need oxygen, and then that oxygen will diffuse into the cells, right? And this hydrogen ion will be accepted by this hemoglobin, right? And when this will be accepted by the hemoglobin, it will form HHB. This is called as hemoglobinic acid, right? When this HHB will be formed, it means that the now the hemoglobin has made this pH decrease to get neutral, right? Because this hemoglobin, when accepting a hydrogen ion here, it is causing the neutralizing effect. It will, you can say, will act as a buffer, right? So this is what we can call as a buffering effect, right? So this is buffering effect when the hemoglobin is accepting hydrogen ions, and when the oxygen molecules are detached from the hemoglobin, or they are sent into the tissue fluid and then into the cells. This is called as Bohr's effect. What is it is called as? Bohr's effect. How can we define it? Bohr's effect is the release of oxygen from the hemoglobin, release of oxygen from hemoglobin, right? And what this is called as the hydrogen ion acceptance, this is called as buffering effect, right? Buffering effect is very important to neutralize the pH of the blood, unless it can cause damage to the body. Are you getting me, everyone? Is that clear?
मैम ये आप लास्ट पार्ट एक को फिर समझा सकती है?
जी जी श्योर, व्हाई नॉट। मैं पूरा पार्ट दोबारा समझा देती हूँ। When there is carbon dioxide that is released by the tissues or by the cells, right, from the tissue fluid, right, this carbon dioxide comes out from the tissue fluid, from the cells, and then into the tissue fluid, and then it diffuses into the red blood cells or in the plasma, right? Not all of the carbon dioxide gets into the red blood cells. Some of it, 5% of it, may dissolve in the plasma, right? And may move in the solution form in the plasma, right? And then 85% of the carbon dioxide undergoes this process, and 85% of carbon dioxide moves in the plasma in the form of carbonates. Now, how these carbonates are formed? Number one, the carbon dioxide reacts with water in the presence of carbonic anhydrase enzyme, and this makes carbonic acid, right? These are the steps I'm writing. And when this carbonic acid is formed, this will dissociate into carbonates and hydrogen ions. And when these carbonates and hydrogen ions are made, fifth step is chloride shift will take place. And this chloride shift will cause the carbonates to come out and the chloride ions will go in. And with that removal of the carbonates outside the red blood cells, hydrogen ions will also come out to prevent the damage to the carbonic acid, right? And when these hydrogen ion concentration will increase in the plasma, right, these hydrogen ions are accepted by hemoglobin, right, to produce a buffering effect. And how this is possible? When the hemoglobin is attached to oxygen, this oxygen is kicked off, right, or it will be detached from the hemoglobin first before binding of hydrogen ions with the hemoglobin. First, it will give off the oxygen molecules and then it will take up the hydrogen ions, now, unless it is not possible. So, these oxygen molecules will move into the tissues fluid and then into the cells, right? And then hemoglobin will bind to the hydrogen ions. And this basically helps in neutralizing the pH, or you can say here the hemoglobin is acting as a buffer. And this effect is called as buffering effect. Now, what do we mean by Bohr's effect? Bohr's effect means that when the oxygen molecules detach from the red blood cells, hemoglobin, and they reach to the tissues present in the in the body, and this kicking off of oxygen, or you can say the release of oxygen from the hemoglobin, is called as Bohr's effect. Is that clear now?
Yes, ma'am.
Adil, आपको clear है? Alize, आपको clear है? Any question you want to ask me?
No, ma'am.
Very nice. Oh, now the question arises that how the carbon dioxide is traveling in the blood, right? 5% of the carbon dioxide is traveling as in solution form. 85% of carbon dioxide is moving as carbonates. Now, what about the 10%, remaining 10% of the carbon dioxide? The remaining 10% of the carbon dioxide move in the red blood cells in the form of, I need some space here. That's why I'm just erasing it, that 10% of the carbon dioxide is moving in the form of carb amino hemoglobin. Carb amino hemoglobin. What do we mean by that? It means that carbon dioxide also has got some affinity with hemoglobin, right? And when carbon dioxide binds with hemoglobin, अब आप कहेंगे कि मैम आपने तो कहा hemoglobin binds to the oxygen and then it binds to the hydrogen ions. Then how come the hemoglobin is binding to the carbon dioxide? So it's not only one red blood cell. There are so many red blood cells. Some of them may bind to the hydrogen ions, and some of them may bind to the carbon dioxide, right? So 10% of the carbon dioxide may bind to the hemoglobin, right? That is hemoglobin, and it forms carb amino hemoglobin. And this basically is a temporary compound. It's not a permanent compound like oxyhemoglobin, right? So that's why it is not very harmful for us. So this is naturally, normally, 10% of the carbon dioxide is traveling in our blood in this form, right? It will not cause any damage. Yes, if hemoglobin binds to the carbon monoxide, that is a harmful toxic chemical released in the tobacco smoke, right? That is dangerous. That is a non-permanent compound. When it binds to the hemoglobin, it never gets reversed. And to reverse it, lots of factors that are conditions that are needed, right? So this is how the Bohr's effect and buffering effect is produced, right, in the blood to maintain the pH of the blood. Number two, we have also done that how the carbon dioxide moves in the blood and in which form it moves, and what is chloride shift and how the chloride shift is important. What is the advantage of chloride shift? I hope that's clear. Now let us have a look on the
मैम
book. जी बेटा.
मैम मुझे कार्बोनिक एसिड होता है वो
हम्म.
किसके साथ रिएक्ट करके वो बनता है कार्बो
कार्बोनिक
हेमोग्लोबिन
एसिड किसी के साथ कार्बोनिक एसिड किसी के साथ रिएक्ट नहीं करता. कार्बोनिक एसिड डिसोसिएट करता है इनटू कार्बोनेट्स एंड हाइड्रोजन आयंस. ठीक है. जो
मैम वो
रिएक्ट कर
फिर वो कार्बो हेमोग्लोबिन कैसे बनता है
कार्ब अमीनो हीमोग्लोबिन. कार्बोनिक एसिड नहीं करता रिएक्ट हीमोग्लोबिन के साथ. कार्बन डाइऑक्साइड डायरेक्ट रिएक्ट करती है हीमोग्लोबिन के साथ समटाइम. और 10% ओनली कार्बन डाइऑक्साइड दैट बाइंड्स टू द hemoglobin and forms carb amino hemoglobin. And this is one
जी
of the
ठीक है
form in which the you can say in which the carbon dioxide is traveling in the blood. Let me show you in your book as well so that you get the idea very clearly, right? Let me show you. Okay, this is the dissociation curve that we have, the diagram that we were talking about, right? You can see here that the carbon dioxide that is moving in the blood in different ways. You can see here that this is the tissue fluid where the carbon dioxide is produced, and then this carbon dioxide is reacting with the water in the presence of carbonic anhydrase enzyme. Carbonic acid is formed, and then it dissociates
मैम
into
ये फिर
carbonates and
कार्बो अमीनो हेमोग्लोबिन का फंक्शन क्या है
it is just carrier. It is just acting as a carrier of carbon dioxide. Like hemoglobin binds to the oxygen and acts as the
जी
carrier
ठीक
of
है
oxygen. So कार्बन डाइऑक्साइड कैरियर है ये एक तरह का. क्यों? क्योंकि कार्बन डाइऑक्साइड की भी सॉरी हीमोग्लोबिन की कार्बन डाइऑक्साइड मॉलिक्यूल के साथ भी एक एफिनिटी है. एंड दिस इज ओनली 10%. ठीक हो गया? इज दैट क्लियर?
जी मैम
Okay, so this is, we are done with chloride shift. We are done with chloride shift. This is a very important topic,
carbohydrate
right? That the chloride shift basically helps in keeping the negative charges balanced outside and inside the red blood cells, right? And this is important to remove overall positive charge from inside, because if the hydrogen ion concentration will increase in the red blood cells, inside the red blood cells, this may cause the more positive charge on the inner side of the red blood cells, right? और उसको remove करने के लिए carbonates come out, and then carbonates के साथ साथ hydrogen ions also come out of the red blood cells to, you can say, maintain the pH and to remove the positive ions from inside the red blood cells to outside, right? Overall, the pH is basically the problem, and this pH is maintained in this way, right? And okay, there is one more graph that I would like to show you here. This one. One of the graph that we did in our last class was this one, that is showing the hemoglobin dissociation curve, and that shows that the partial pressure of oxygen when increases, the hemoglobin saturation also increases, right? And this situation is in the lungs, I told you, and this situation is in the tissues where the oxygen saturation with hemoglobin is decreasing, right? And this curve is showing you the same thing, but under two more factors, two more effects that we have seen here. The effect of changes in the carbon dioxide concentration on the hemoglobin saturation with the oxygen. What does it mean? It means that when the carbon dioxide concentration is low, for we in this curve we have just talked about the oxygen's partial pressure, right? We have not considered the carbon dioxide concentration, that whether it's low or high. But in the next curve we are also checking the effect of carbon dioxide concentration on the sigmoidal curve, or you can say the dissociation curve. So this dissociation curve of hemoglobin is at two different partial pressures of carbon dioxide. One is low and one is at high carbon dioxide concentration. You can see that. And the shift of the curve to the right when the hemoglobin is exposed to the higher carbon dioxide concentration is also called as Bohr's shift. हमने Bohr's effect पढ़ा है ना? This is called as Bohr's shift. What do we mean by Bohr's shift? Bohr shift means that when there is low carbon dioxide concentration, the hemoglobin saturation is maintained or is achieved quickly or efficiently, even at low partial pressure of oxygen. For example, let me give you an example here. I cannot make the straight line here, but I'll try my level best. So for example, this is the 4 oxygen partial pressure, and this is the hemoglobin saturation. Wait, this is the hemoglobin saturation when the carbon dioxide concentration is, it is not responding. Just wait for a while. It may start responding. Microsoft Edge is not responding. I don't know why. Okay. So at this 4 carbon dioxide oxygen's partial pressure, at low carbon dioxide concentration, the hemoglobin saturation is this. At the same partial pressure of oxygen, the hemoglobin saturation is this. 60% and 40% hemoglobin saturation is there, right? Why? Because at high carbon dioxide concentration, when in the tissues, near to the tissues, the oxygen's partial pressure is less. Although here in the graph, what we can see, at higher carbon dioxide concentration, the oxygen where the oxygen partial pressure is same, that is 4, but the hemoglobin saturation will be more if the carbon dioxide concentration will be low, right? And if the carbon dioxide concentration is high and the oxygen's partial pressure remains same, the hemoglobin saturation may decrease. Why? Because of the carbon dioxide more concentration. Now, what is the reason behind it? Just think over it, that why the at higher carbon dioxide concentration and at the same where the same oxygen concentration or the oxygen partial pressure is there. So why the hemoglobin saturation is less at high and more at low carbon dioxide concentration? Any idea? The reason behind it is The reason behind it is that at high carbon dioxide concentration, imagine where there will be high carbon dioxide concentration, where there are tissues, respiring tissues are present and they're respiring, they're giving off carbon dioxide, and they are disturbing the blood's pH. And at that time, the hemoglobin may kick off oxygen, will do the Bohr's shift, and will bind to the carbon dioxide so that to neutralize the pH of the blood, because carbon dioxide is an acidic gas, right? And at higher partial pressure of oxygen, obviously it is in the lungs or it is somewhere where the respiring tissues are not producing much carbon dioxide, or where there is no less carbon dioxide is no, I can't say, where there is less carbon dioxide is available. So the hemoglobin saturation will always be high with oxygen, right? Because there is no danger present. There is no danger to the pH disturbance that is present. So this is why this Bohr's shift is taking place at high carbon dioxide concentration. I hope you got it.
Yes, ma'am.
अंश आपको समझ आया बेटा? What do we mean by the Bohr's shift? Why this and examiners give this question a lot. Cambridge gives this question a lot. They make just one curve, right? And they just don't make the other curve. And they ask you that if the carbon dioxide concentration will increase, right? So what will be the change in the curve? You will write it, you will make it on the right as it is made here in the graph, right? Can you see that? ठीक है? And this is called as this effect is called as Bohr's shift. Is that clear?
Yes, ma'am.
मैम या फिर से
Okay.
एक्सप्लेन करा सकती है?
जी बेटे, why not? जो फर्स्ट आपको ग्राफ नजर आ रहा है, this one, right? This one I'm talking about. ठीक है? This graph is showing you the hemoglobin dissociation curve, right? When the just leave this higher carbon dioxide and lower carbon dioxide. Just forget about these first, right? When the oxygen partial pressure is increasing, the hemoglobin dissociation, hemoglobin saturation is also increasing, and then it becomes maximum, right? Now, when we see these two curves, why these two curves are like that? Because we are now also considering the concentration of carbon dioxide. When there is low carbon dioxide concentration, obviously there is no pH disturbance is there, less pH disturbance is there. So more hemoglobin saturation will be there with oxygen, not with carbon dioxide. But when the carbon dioxide concentration increases, the hemoglobin dissociation curve shifts to right. This is called as Bohr's shift. Why it is shifting to this right? Because of the high carbon dioxide concentration. The reason behind it is that when there is higher carbon dioxide concentration present in the surrounding of the hemoglobin, hemoglobin will not bind to the oxygen. It will show you more affinity with the carbon dioxide, and it will bind with the carbon dioxide instead of oxygen. So that's why its saturation will be low with oxygen at higher carbon dioxide. I've just given you an example here. That, for example, at 4 or at 2, you can see at any point. At 4, you see the hemoglobin saturation is this at high carbon dioxide concentration. And at the same oxygen partial pressure, the oxygen saturation with hemoglobin saturation with oxygen is 60%. So why this difference is there? This difference is there because of the carbon dioxide concentration. Is that clear now?
Yes, ma'am.
Okay. Alize, is that clear to you?
मैम वो नहीं है मीटिंग में.
Oh, Alize is not there. Okay, she is going to see the video. Okay, no problem. So have a look here on this curve, the other one. It's the same. But what they have told us about the tissue's presence. At low partial pressure of oxygen, whether the carbon dioxide concentration is high or low, the hemoglobin saturation is less. Why? Because it is near to the active tissues. I just told you, right? And because the muscles or the cells are respiring continuously and they're giving off more carbon dioxide, and that's why its saturation with oxygen will be less, right? And this will be the condition where there is lungs or the in the lung capillaries. This section of the curve is the relevant one. Why? I just told you in the beginning that in the lungs the partial pressure of oxygen is high. Even if the carbon dioxide concentration is high, the hemoglobin saturation will be more with oxygen because of the higher carbon oxygen partial pressure in the lungs, right? It's the same. They have just shown you what they have not shown here in this curve. I've shown you here that this situation will be this relevant curve side will be in the lungs capillaries and this will be in the respiring tissue. It's the same thing that they have shown you here. It's the same thing, right? I hope that's clear. Inshallah, I'll see you tomorrow.